Google has introduced a new technique called TurboQuant that focuses on one of the biggest limitations in modern AI systems: memory usage. Running large AI models requires a huge amount of memory, especially when the models are deployed in real-world applications like chatbots, image generation, or recommendation systems. This is because these models store billions of parameters, and each parameter takes up space. The more memory required, the more expensive and slower it becomes to run these systems at scale. TurboQuant is designed to reduce that memory requirement significantly, by roughly 6 times, without causing a major drop in performance. That balance is what makes it important. To understand how it works, it helps to know the basic idea behind quantization. In simple terms, quantization is a way of compressing numbers. AI models normally use high-precision numbers, such as 16-bit or 32-bit values, to store weights and calculations. These provide accuracy, but consume a lot of memory. TurboQuant reduces the size of these numbers. Instead of storing full precision values, it uses lower precision representations, which take up much less space. The challenge with this approach has always been that reducing precision can damage the model's accuracy. Outputs may become less reliable or inconsistent. What makes TurboQuant different is how it manages this trade-off. Rather than applying a simple uniform compression across the entire model, it selectively adjusts precision depending on how important different parts of the model are. More sensitive layers or parameters keep higher precision, while less critical ones are compressed more aggressively. This targeted approach allows the system to maintain strong performance, even with much lower memory usage. Another key point is that TurboQuant is designed for practical deployment, not just research experiments. It works with existing model architectures and can be applied during inference, which means it helps when models are actually being used, not just trained. This is where most of the cost in AI systems comes from, especially in large-scale services. Reducing memory by 6 times has several direct effects. First, it allows larger models to run on smaller hardware. This means companies can deploy advanced AI systems without needing extremely expensive GPUs or large server clusters. Second, it improves efficiency in data centers by lowering power consumption and increasing the number of models that can run on the same infrastructure. Third, it can reduce latency, because smaller models can be loaded and processed faster. This also has implications beyond large companies. Developers in smaller organizations may find it easier to run advanced AI models locally or on more affordable cloud setups. In some cases, it could even make it possible to run more capable AI directly on edge devices like smartphones or embedded systems. In the broader context, this move fits into a growing trend in AI development. Instead of only making models bigger, companies are now focusing on making them more efficient. Improvements like TurboQuant aim to get more value out of existing models, rather than simply increasing their size. In simple terms, TurboQuant is about doing the same work with far less memory. It does not change what the model is capable of, but it changes how efficiently that capability is delivered. That shift is important because the future of AI will depend not just on how powerful models are, but on how easily and widely they can be used.